In the previous sessions we had discussed enough on the S matrix. So today we are going to deal with something which is new, which is called as the T matrix. Where do I need T matrix? Whenever you want to cascade high frequency networks, you will go for T matrix. Suppose I have a two-port network like this and another two-port network like this. And you want to cascade both these fellows. In this condition, you will use a T matrix. You will use something called as a T matrix. So now let me call this as A1. This fellow will be B1. This fellow will be A2. This guy is B2. So this will be A1 dash, B2 dash, B1 dash, A2 dash, B2 dash. So let's write the T matrix of this network. The T matrix of a single two-port network. Can be written like this: A1, B1, T11, T12, T21, T22, B2, A2. This is the T matrix of this two-port network. Now let's write the T matrix of this two-port network. I can write this as A1 dash, B1 dash, T11 dash, T12 dash, T21 dash, T22 dash, B2 dash and A2 dash. Now look at this network. What is B2? B2 is the output signal. This output is entering into the second network. If you cascade both these fellows, two fellows, then this fellow is the signal that is going to enter into this. So what I'm just going to do is I'm going to rewrite this fellow. I'm going to write this as B2 and this as A2. I'm just reorganizing the diagram, nothing. So what happens? This is the output signal. So what happens to this output signal? It is entering into the second two-port network. The signal which is coming from A1 is being processed in this two-port network and it is coming out as B2. Now this signal is entering into the second two-port network. So B2 will be equal to A1 dash. So B2 will be equal to A1 dash. And what happens here? Look at this fellow. When I have a signal here, when I give an input signal here, this signal will come, this will be processed here and it will come out. This is B1 dash, this is the direction of B1 dash, right? I've drawn it wrong. So what happens, there is a signal which is entering into the two-port network and it comes out of B1 dash. So the reflected signal will enter into the first port. It will enter into the first network. So what happens, B1 dash is equal to A2. B1 dash will be equal to A2. Am I right? So both these fellows will be the same. So the output of the first network will enter into the second network, and if you give a signal from this side, what happens? The output of this network will enter into the network by A2. So naturally B1 dash will be equal to A2, or A2 is equal to B1 dash. Now if you compare these two equations, I can rewrite this equation as A1, B1, T11, T12, T21, T22. Now what is B2? B2 is equal to A1 dash. What is A2? A2 is equal to B1 dash. So I can write this as A1 dash, B1 dash. Now what is A1 dash, B1 dash? We have it here. So I can write A1, B1 is equal to T11, T12, T21, T22, T11 dash, T12 dash, T21 dash, T22 dash into B2 dash, A2 dash. This will be the T matrix of the entire network, of the entire network. So whenever you have two networks to be cascaded, especially high frequency networks, you have two high frequency networks, you want to cascade them, then we will go to the T matrix. So it's just similar to our ABCD matrix. It's just similar to our ABCD matrix. In low frequency circuits, whenever we need to cascade two networks, we will choose ABCD matrix. Similarly, when we go for high frequency networks, whenever we want to cascade two networks, we will go for T matrix.